Thank you. Let's do that again. That was fun. Good morning. Hi. Welcome to the 20th Annual Fannie and Charles Pentecoff Research Symposium. I'm Holly Messick. I am the chapter president for the National MS Society in Greater Illinois. I started December 1st last year, so I didn't get to come to this event. So I'm excited to be at my first one, and I'll have the chance, hopefully, to meet those of you I haven't throughout the day today. I know that there's some attendees here who are feeling a lot of anxiety about the Cubs game today. Yes, Dr. Nguyen. It's very exciting to be in Chicago at this time. I did have the pleasure of being with some of our amazing support group leaders last night and family visit volunteers, and just to really be inspired by the work that all of you are doing. So those of you that are here today as well, thank you so much for giving up your time yesterday and being here today. And really, all of you in the room, thank you for being here, not only to hear and learn for yourself, but also for others in your community. I think it's really important, and we at the National MS Society appreciate that very much. The mission of the National MS Society is to ensure that people affected by MS can live their best lives as we stop MS in its tracks, restore what has been lost, and end MS forever. Programs like today's Research Symposium bring us closer to our, to our ultimate goal of a world free of MS. It is very exciting for MS research in the US and throughout the world. Over the course of the past year, the National MS Society has invested more than $51.5 million to support over 380 new and ongoing research projects, including more than 20 that are right here in Illinois. And some very exciting news this week, the National MS Society announced that they have made a multi-year commitment of over $21 million to support an expected 78 new MS research projects. And I had the opportunity to be in our New York office this past week and to learn with some of my peers and to know that over the next year we are targeting to again invest more than $53 million in MS research across the world. So it's just a really exciting time. And part of why I chose to come to the MS Society was I was so impressed that we really are leaders in encouraging others across the world and other organizations even to be investing in research no matter where it is, and really to make sure that we're funding the best research to end MS forever, and really taking that as a charge for us to be leaders in. So I was really proud to be a part of this organization, and that's part of the reason I joined. This morning, you will hear about some of this research from our keynote speaker, Dr. Robert Model of the University of Illinois at Urbana-Champaign, followed by a panel of neurologists who will answer many of your questions. We have an informative program in store for you. I would like to acknowledge the Fannie and Charles Pentecoff Trust, and yes, definitely. You're such good applauders so early in the morning. I appreciate it. Our Health Expo sponsor, Biogen. Our gold sponsor, Genzyme, as well. Thank you. And to all of our supporters that make today possible, and to all of our volunteers and staff and board members who are in the room, thank you so much for your support for this event, as well as throughout the year. I'd now like to turn the stage over to Amy Perrin-Ross to introduce our keynote speaker. Amy is currently the chair of the Greater Illinois Chapter's Clinical Advisory Committee, is the coordinator of the MS program at Loyola Medical Center, and is a 2012 inductee in the Health Professionals Hall of Fame. So thank you so much, Amy, for being here. Amy?
Thank you, Holly, for your kind introduction. Welcome, everybody. It's so nice to see so many friendly faces, many familiar faces, and yet I've gotten to meet some new faces today, and that's extremely rewarding for me to know that there are so many people with so much interest in the lives of people with multiple sclerosis. So I'm looking forward to today's programs, and in just a few minutes I'm going to be introducing our keynote speaker, Dr. Rob Model. who's going to be addressing us with the topic of exercise in MS, symptom management, or disease modification. I think he'll provide us with some very interesting concepts and some interesting thoughts and things to mull over. Now, immediately following the presentation, there's going to be an opportunity for a question and answer session. And for those of you that have been here before, you know that what we will ask you to do is to use the pens and the cards that are on each of your tables to write down your questions. Since I'm the one that needs to read those questions, if you can print, that is always helpful, believe me, because I would like to make sure that I get to as many of your questions as I can, and also to be sure that I'm asking exactly the question that it is that you are interested in. Now, after the cards are collected at the end of Dr. Mottle's presentation, I will welcome up 3 additional panel members who are esteemed neurologists in the Chicago area who are also going to be addressing many of these questions. So they can be directed at either Dr. Mottle or any of our panelists. Now, all of our panelist bios are in your program booklet, so I'd encourage you to take a look at those as well. So without further ado, I'm actually quite pleased to introduce our keynote speaker, Dr. Rob Mottle, who is from the University of Illinois at Urbana-Champaign. Now, Dr. Mottle is a person who I've gotten to know over the years. He does a lot of volunteer work with a lot of the organizations that I work with, and I consider Dr. Mottle not only a colleague, but a friend. And I'm always amazed at the amount of energy that Dr. Mottle has. He is a man who has spent a tremendous amount of time and continues to spend that time mentoring healthcare professionals, and I think you'll hear a little bit about his work. He is an active supporter of education for healthcare professionals at the Consortium of Multiple Sclerosis Centers meetings, and he's such an active supporter that he usually brings a team of people with him every year and makes sure that they submit multiple abstracts, whether for poster or platform presentation. And as a result of that, and the tremendous amount of work that he does, that he's going to be talking to you about, he has won for the last 4 or 5 years research awards for platform or poster excellence at the consortium meeting. So I'd like to congratulate Dr. Mottle and encourage him to continue that effort. As I said, Dr. Mottle is a professor in the Department of Kinesthesiology and Community Health, and he's also the director of the Exercise Neuroscience Research Laboratory. His research is exclusively focused on persons living with MS over the past 10 years. And over the past 10 years, he's been continuously funded by the National MS Society that has resulted in over 350 peer-reviewed published papers. That's an amazing accomplishment, Dr. Mottle. Last year, Dr. Mottle was inducted into the National MS Society's Volunteer Hall of Fame in the area of scientific research. He's been a longtime member of the Greater Illinois Chapter's Clinical Advisory Committee, and having been chair of that advisory committee for the past 6 years, I can tell you that he's been active when he can, whether that means driving up from Champaign, Urbana, and fighting the traffic on I-55, or simply phoning in and being an active participant in the meeting. He's always there to support us. He serves on the committee's scientific peer review committee and was an influential member of a work group convened in Greater Illinois to determine the most effective way to manage research funds created by the Illinois Lottery and the Illinois Department of Public Health. So please join me in welcoming Dr. Rob Mottle. Rob?
Well, good morning. It's quite an honor to be here today, and Amy has brought the level of pressure and stress up to an entirely new level. Thank you, Amy. Please forgive me this morning if I don't seem as gregarious and sociable as usual. I'm feeling a little bit under the weather. My wife and kids have bronchitis, and I think I'm soon to follow. And so I apologize for that. This is quite an honor. I was very surprised and shocked when Colleen contacted me to fill in, and then Colleen asked me to do something a little unusual. She asked me to give a talk that was controversial and potentially inflammatory, and I guess that means that my usual talks are boring, and that I needed to elevate to a whole new level. And so I thought one of the things that has been on my mind quite a bit lately is whether or not exercise is simply an approach for managing the symptomatic consequences of MS, or whether or not exercise might be something that has a disease-modifying role. And so, as you can tell from the title, that's what I will talk about today. What's that? Just before I begin, I do need to note some disclosures. I am on Speakers Bureau for EMD Serono. I'm a consultant for Biogen IDEC and Accorda Therapeutics. I have funding from Biogen IDEC, Accorda Therapeutics, Sun Health Technologies, the MS Society, the Consortium of MS Centers, and NIH, and I secretly hope to look like Dan Wynn someday. This is a picture of a gentleman who's 80 years old and exercises on an ongoing basis. I hope we all can aspire to look that good. I have a bias. I believe that we need to make sure that we do healthy things. A lot of people do unhealthy things. Smoking 500 cigarettes at once, I don't quite think that that is the healthiest thing in the world to do. Or eating a hamburger that has glazed donuts on the side with lots of bacon in between. Maybe a little salad. So what am I going to talk to you about today? I'm going to provide a framework for how I'm going to make an argument for exercise as disease-modifying versus symptomatic. I'm going to then talk about research evidence about exercise and disease modification and different outcomes that might provide us with some evidence that exercise is indeed disease-modifying. I'll then move on to exercise and symptomatic outcomes. I'm going to talk a little bit about participation rates and resulting guidelines that are in place that have been developed to try to overcome the low rates of physical activity and exercise uptake in MS. And then I'm going to talk about next steps in this research agenda. So first and foremost, let's start with our platform or framework for how we're going to evaluate, or I evaluated this question. So I took a non-scientific survey of neurologists, 10 of them, and I got different answers about how to establish what is disease-modifying from an outcome perspective. Some individuals told me that I needed to look at the effects of physical activity and exercise on the progression of disability. That is, looking at whether or not physical activity and exercise can slow down or delay the progression of disability over time, and I thought that that was a very good outcome. Other individuals told me I need to look at the effects of physical activity and exercise on the rate of relapses in individuals with MS, as that seems to be a direct marker of periods of disease activity. I was further informed that I needed to look at the effects of physical activity and exercise on metrics from magnetic resonance imaging, and that I needed to look at two things. One would be to look at lesions. One would be to look at enhancing lesions, which there are no data on physical activity and exercise. The other would be to simply look at the volume or number of lesions in the brain. And then secondly, to look at specific regions of interest in the brain, areas that are associated with functional declines over time. And lastly, that I might think about looking at animal models or preclinical research and whether or not physical activity exerts an effect there. These would be things that were comparable across the 10 different opinions that I sought, and so I will stick with them today. On the symptomatic management side is to look at the effects of exercise on functional outcomes. Look at things like fitness, walking, and cognitive functioning, as well as maybe balance. To look at things like symptomology, for example, fatigue and depression, and then to look at an outcome that is the root outcome that I think we all are ultimately interested in, that is maintaining a high degree of quality of life. Now, the next question is, once I identify these frameworks, these factors that go into the framework is, can we identify the question or answer the question, and how well can we do that? And so one of the things that I thought about is, well, we needed to look at the research design. And there's a lot of variability in the types of evidence that I'm going to talk to you about today relative to how good the research design is. Some of the data is just simply looking at a cross-sectional period of time. That is, just measuring physical activity and measuring outcomes in people with MS. And those types of data are really important data for telling us that there might be something of value to look at in longitudinal or clinical trials. But they do have some inherent limitations in them. Some of the data are prospective. That is, they are looking at physical activity and exercise and trying to understand what develops or unfolds over time, much like when we are watching a movie. We start with a premise and we try to see what happens over the course of that movie. And then some of the trials that we'll talk about are experiments. That is, they're studies that manipulate exercise and physical activity behavior and examine the ultimate consequences of that health behavior change. We have to be wary of the duration of many of these trials. Many of the exercise trials that we look at are as short as 3 to 6 months, and it's really difficult to understand whether or not you've truly modified the disease in this very short period of time. Most larger drug trials utilize 1 to 2 years, if not longer periods of time, and so we'll have to keep that in mind. And lastly, we need to keep in mind whether or not these are primary or secondary outcomes. Oftentimes, these studies are, or the outcomes I'll pull from studies, are secondary observations from trials. And there's a lot of difference in opinion as to whether or not that's a good or a bad thing. Oftentimes, people want to see an outcome as the primary objective of the trial. I think that that can sometimes be biased because researchers are intending to specifically change that. And oftentimes, looking at secondary outcomes, those aren't the specific target, and they can provide us some really interesting and rich data about things that individuals captured but weren't really trying to focus on. And maybe that allows us to move beyond some researcher bias. The other things we need to think about are the context of the sample that generate these data. We know that oftentimes these data are generated in individuals who have very low to moderate levels of disability. And Lara Paludi will talk with you this afternoon about data on exercise and physical activity in individuals who have more severe dysfunction with the disease. Oftentimes, the data are collected in individuals with relapsing remitting multiple sclerosis, so they're limited to a specific type of the disease, and individuals who have a shorter duration of disease. One of the things that we don't know a lot about is how exercise is independent or combinatory with disease-modifying therapies and other symptomatic agents, because these are not oftentimes contextualized or captured in the research studies. And lastly, we know that the majority of the studies have women in them. Women seem much more willing to volunteer for research than do men. Men, change that. We need to understand more about you. Women seem to volunteer. And I know MS occurs in women more often than men, but we still need more men to volunteer. And the last thing we need to think about is the age. Most of these studies are done in individuals who are in their 30s and 40s. And one of the things that we're recognizing right now is that MS and the landscape of MS is changing to reflect the basic demography of the United States. That is, there are more and more people in the United States who are older than younger, and that will occur through the history of time. And we're seeing that more and more people with multiple sclerosis are reaching into the older age groups. That is, the most prevalent age group of people with MS right now is in the late 50s and early 60s. So we're seeing a lot of change in the landscape, and we need to be aware of that as we move forward. So with that being said, let's talk about the evidence. So first, we're going to talk about the case for exercise and disease modification. And I want to point out that this is not a new idea. I just didn't kind of pull this out of the hat and come up with something that hasn't been thought of before. I've, in large part, borrowed from this really amazing book by Jock Murray, which really is titled Multiple Sclerosis and the History of a Disease. However, upon reading this book that I believe is close to 1,000 pages, I was struck I was struck by how often exercise and physical activity were introduced into the treatment of MS at very early stages of our understanding of MS, dating all the way back to the days of Charcot, who is oftentimes given credit with understanding and naming this disease. So exercise and physical activity has long been brought into the treatment modality for managing the disease itself. Secondly, there's this very nice paper by Ulrich Dahlges out of Europe that has actually proposed that exercise might be a good therapy for slowing down the progression of the disease. So I bring this up because I don't want you to think that I'm the first to come up with this idea, but I also don't want you to think that this idea is coming up in isolation. There are lots of individuals who are thinking about this right now. So let's turn to the first step of the data. The first step of the data is to look at the effects of physical activity and exercise on the progression of disability in individuals with multiple sclerosis. And so these are some data that I'm going to present to you today that I collected in collaboration with Dr. Nguyen. And what we did is we received a grant from the National Multiple Sclerosis Society to recruit a sample of about 270 individuals with relapsing and remitting multiple sclerosis. And we followed these individuals every 6 months over a 2-year period of time. And we did that to track the progression of disability. And what you'll see is that on the x-axis we have time here, and on the y-axis we have disability status, and a higher score indicates worse disability. And what you see happening, generally speaking, in the sample is that disability every 6 months is progressively getting worse. And that's very consistent with the literature that we see in multiple sclerosis, that disease progresses over time. The second thing that we are interested in doing is trying to understand the variability in that progression. And so we separated our sample into groups of individuals who were low active and individuals with who were high active to see if that influenced the progression or the rate of disability over time. And what you see is quite staggering. We see that the group of individuals who are low active, that is, they don't participate in high volumes of physical activity, are essentially worsening in disability status over the course of this 24-month period. If we look at individuals who are engaging in high volumes of physical activity, their disease progression is stable. And the important thing to note in this study is we did collect data with a lot of help from Dan Nguyen on whether or not patients were on disease-modifying therapies, and this relationship is independent of the disease-modifying therapies that individuals are using. So this is the first answer in our question of exercise and disease modification. Physical activity seems to delay the progression of disability over time. The second data comes from a meta-analysis that one of my former graduate students, Aaron Snook, published many years ago. And these are data looking at the effects of exercise on walking mobility as one of the primary aspects of disability progression. And in particular, these studies were included that include this neurological evaluation that generates the Expanded Disability Status Scale score, which is the gold standard of measuring disability over time. And these studies that are lined up along this column here represent individual studies that have looked at the effects of exercise on disability compared to a control group. And what you see is, overall, there is a reduction in the effect, or there is a reduction in disease progression with exercise training compared to doing no exercise. That is, exercise actually reduces the amount of disability that individuals accumulate from before to after the trial compared to the control condition. This effect is comparable with that observed in clinical trials of disease-modifying therapies. The amount of improvement is identical with the amount of improvement based on meta-analyses of disease-modifying therapies in MS. So what this suggests is that exercise seems to have as large effect as disease-modifying drugs. The second important observation is that we can double the size of the effect that we see when we have well-designed, supervised exercise training interventions. Why is this important? Well, if we can double the size of the effect with exercise training, we are now suggesting some degree of superiority. to disease-modifying therapies. Controversial enough, Colleen? So the other thing that we've had the pleasure to do is to look at the effects of exercise on adverse outcomes in persons with multiple sclerosis. And this is a paper published by Lara Paludi, who will be talking this afternoon. And what we started to do in this study is to understand whether or not there were adverse events associated with exercise training in persons with MS. And what we were delighted to find is that the majority of these studies, in addition to reporting adverse events, also reported the rate of relapse in exercise and control conditions. So now we can look across all of these studies, combining them together to understand whether or not exercise is associated with a differential rate of relapses compared to the control group. And what we find is, across these studies, when we amalgamate the data, there is a relative risk of relapse in the exercise groups of 0.75 compared to the control groups. This represents a 25% reduction in the rate of relapse with exercise training compared to not receiving exercise training. So it's suggesting that exercise can actually reduce the rate of relapses in persons with multiple sclerosis. We've further been very interested in and generating a lot of data on looking at physical activity and MRI outcomes. And this is a paper that we've recently published in the Journal of Neurology, looking at physical activity and its relationship with lesion volume in children with multiple sclerosis. And this is a study that's done with Ann Ye and Brenda Banwell, who are both at Sick Kids up in Toronto. And what we were able to show in this study is more physically active kids have a lower rate of accumulating lesions over time. They also have a lower rate of relapse accumulation over time. And this is really important because in children with MS, you actually see a higher rate of relapses and lesion volume accumulation over time. And so it allows us to look at the effects of physical activity in the context of a very, very rich period of disease activity and potentially even show stronger effects of physical activity. The second study over here are data that we published many, many years ago, actually about 10 years ago, looking at aerobic fitness as a marker of exercise training and whether or not it affected gray and white matter integrity in persons with multiple sclerosis. Buried in here, to my dismay, is the fact that individuals who have higher levels of aerobic fitness, which suggests that they're more engaged in aerobic exercise, have fewer lesions and a lower volume of lesions compared to the less fit individuals. And lastly, we don't have to think too far. We're all aware of Homer Simpson and many of his different characteristics. Well, these are recent MRI data looking at Homer's brain, and he has some atrophy. We've been looking at physical activity in different regions of the brain, specifically regions associated with walking and cognitive functions in persons with MS. And what we've shown is that individuals who are more fit, who engage in more aerobic exercise, have greater volumes of the thalamus, which is important for information processing speed. They have greater volumes of the hippocampi, which are important for learning and memory, and they have larger volumes of the basal ganglia structures, which are important for ambulatory outcomes. And we've confirmed this with physical activity as another marker or behavior. In our most restrictive models, you can see that moderate to vigorous physical activity is across the board associated with different measures of the integrity of structures in the brain that are important for functional outcomes. And this is independent of disease status and other important contributors. So it's really starting to make us believe that exercise is important for the brain health of individuals with MS. And one important question that I often get is, how in the world could this happen? How in the world could exercise affect the brain? And the answer is quite clear. These are data from Carl Kottman, who is one of the foremost researchers in looking at exercise and its effects on expression of a nerve growth factor called brain-derived nerve growth factor. This nerve growth factor is important for developing new neural connections and new neural cells in the brain. And these are audio-radiograms of labeling of BDNF in the hippocampus. You can see hippocampus is a seahorse-like structure. This is a picture of an animal that ran for a lot. And this is a picture of an animal that didn't run at all. And when you look at these two pictures, the evidence is clear. There is a lot more expression of BDNF in the animal that runs in a brain structure associated with learning and memory. These data over here just support that observation with mean level data. And the question is, well, why would exercise affect the expression of a nerve growth factor associated with developing neural tissue with learning and memory? And this is a recent paper in the journal Cell Metabolism that has identified specifically the pathway. When individuals exercise and activate their muscles, they start a cascade of regulatory responses. Those regulatory factors that are released into the bloodstream circulate and cross into the blood-brain barrier. They cause the expression of BDNF to occur, and that results in nerve growth and the other outcomes. Now, the real selling point of this study is they didn't just look at what happens with exercise in this cascade of events, but they isolated this specific regulatory factor and injected it into sedentary mice and saw the exact same effect as those mice that ran. So it really has isolated the cascade of events that exercise could influence brain regulatory processes and brain tissue itself, with an outcome of managing the disease. Lastly, preclinical work with animal models of physical activity. So this is a nice animal model that a lot of people in Ohio use. That's an Ohio license plate. I picked it on purpose as a non-Ohio fan. Of walking your animal outside of a car. If you have an animal and they need to be walked, walk with them. But what we have done is, and this is a paper by Rachel Claren with Steve Miller from Northwestern, where we reviewed all of the research on exercise in animal models of multiple sclerosis. And I emphasize that these are animal models that result in a mimicker of what we think we see in human MS. And what these data show can be seen on this far figure over here. So we have the progression of time. We have the degree of impairment in these animals. We have one pair of animals that is the control animals who are not physically active. We have another set of animals that are physically active. They induce the disease by injecting a specific protein that the body responds to, or the animal responds to, and at the same time, they start having these animals be exposed and have access to exercise and physical activity. And they watch what happens over time. And what you see happen is the disease starts at about the exact same period of time. It gets much worse in the sedentary, non-exercising animals. It stays lower in the active animals. So these data are suggesting at the level of the animal model, exercise is slowing the progression of the disease. Why does this matter? Well, this is often the test bed that is using animal models to come up with new disease-modifying therapies before we go into human trials to show that they might work. Well, these data are showing that exercise works in animal models. Now, the only problem with these data that we want to point out is that exercise is done when the disease starts. And that has a little bit of a translational difficulty to humans because humans would start exercising after they have the disease. And we are busily working on animal model research right now, looking at the effect of introducing exercise after the expression of disease, and maybe in a few years I'll have a good story for you. So, now the case for symptom management. I feel like we should have dueling pianos up here. So one of the things that people have been very interested in is the effects of exercise training on aerobic capacity. And we measure aerobic capacity by putting an individual on a bike, hooking them up to a mouthpiece, and collecting all of their expired gases when we push them to the point of maximal effort and exhaustion. And we have used this as an important outcome in lots of exercise training studies because aerobic capacity is essential for maintaining independence in daily life. If you don't have the aerobic capacity reserve or high level of this, you lose your capacity to function independently. So this is a very important outcome. And what all of these studies show is that exercise improves aerobic fitness in persons with MS by about a half standard deviation. And this is an effect size when we compare it to other studies outside of MS that seems to be large enough to maintain independence in daily existence. So this is a big effect and a very important effect. We've also looked at the effects of exercise training on muscle strength. That is, the ability, when we strap you onto an isokinetic dynamometer, for you to generate a lot of muscular force with a maximal contraction. And what we've shown here is, again, if you look across the board at exercise training studies, engaging in exercise training allows individuals to improve their strength. And that is very important as well, because if you don't have strong muscles, walking up the stairs or walking up a ramp of these natures becomes very difficult for individuals with MS. So again, we can link this all the way back to outcomes of daily living. A lot of individuals have been interested in the effects of exercise on other outcomes like cognition and balance. And, well, this is Albert Einstein, and he's on a bike, so exercise must have resulted in the discovery of many of our basic principles that we live with in the laws of physics, right? Absolutely. Well, we know when we look outside of the world of MS, exercise has very, very profound effects on cognitive functioning. In fact, some colleagues of mine at the University of Illinois produced the first knowledge on exercise and cognitive functioning in older adults, and they published these data in Nature. But the true litmus test of how good their data were was that Saturday Night Live picked up this story. And Weekend Edition ran a story saying that researchers at the University of Illinois have shown for the first time that exercise improves memory in adults, which was great. Then they flipped to the next screen, which was a picture of then President Bush running, and they said there are some exceptions. One of the things that we've been spending a lot of time on is looking at the effects of exercise and cognitive functioning in multiple sclerosis. And I don't have a good answer for you yet whether or not exercise is effective for improving cognition in MS. Some of the more recent trials are starting to show very nice positive effects, but the earlier studies didn't show these benefits. And so I'm not in a position to say exercise, it will improve your cognitive functioning, but we're moving in that direction, and hopefully we'll have those data soon. And the same thing with the effects of exercise on balance. And I know that these are very important outcomes for people with multiple sclerosis. We've looked a lot at exercise and its effects on fatigue. And these are data published by Lara Paludi, who you'll hear later today, looking at the effects of randomized controlled trials of exercise training on fatigue in persons with multiple sclerosis. And the end of the day story is that exercise improves fatigue by half standard deviation. And we were very curious as to whether or not this is a clinically meaningful effect and how to judge whether or not this is a clinically meaningful effect. And what we discovered in looking at our data is that when we expressed this effect in the context of change on standard fatigue measures, this magnitude of effect was large enough to take individuals out of a range where they had severe debilitating fatigue and putting them into a range of scores where they have less debilitating fatigue. So we believe that this is clinically significant. The second thing that's been done by Marcia Finlayson, who used to be a stalwart at this meeting before she moved to Queen's University in Canada, is exercise versus other approaches. And what these data show you here is that exercise is effective and fatigue management is effective, and there doesn't seem to be a differential impact of these two treatments independently on fatigue. What becomes very interesting in this study is they also looked at the effect of drugs, pharmacological agents for managing fatigue. And what this far side shows, you may not be able to read it, is that pharmaceutical approaches that have been studied in randomized controlled trials are not effective for managing fatigue, whereas exercise and symptom management or fatigue management approaches are. And we thought that this was very, very intriguing. We've looked a lot at depressive symptoms. We know that depression is a big problem in multiple sclerosis, and we've been interested in whether or not exercise can manage depression. And what we've seen is universally across the studies that exercise has a favorable effect on depression in persons with multiple sclerosis. And the effect seems rather small at first glance, but when you start to look at whether or not people meet physical activity guidelines for exercise and physical activity for benefits, the effect is twice as large, and it approaches an effect that's large enough to reduce depression to below a clinical threshold. Almost to the end, we need to talk about walking and walking outcomes, because walking is such a big problem in MS. And this is a recent meta-analysis showing exercise training effects for improving walking in persons with multiple sclerosis. And the end of the day story is right here. They show that exercise improves walking endurance and speed. If we measure it by the 2-minute walk test, we get a 12.5 meters further walking with exercise training compared to control conditions. If we look at the 10-meter walk test, we see that individuals improve by nearly 2 seconds. And so again, one of the things that we need to know is whether or not this translates into any real-world benefit. And so I went back to a paper that I published with Mila Goldman in Neurology a few years ago, where we developed buckets or benchmarks of time 25-foot walk performance. And this change is enough to move someone out of a benchmark or bucket where they're at risk for unemployment and disability into a bucket where they're not at risk for those outcomes. So again, this seems to be, it might look like a small improvement approaching 2 seconds, but that 2-second improvement translates into something quite meaningful. Lastly, quality of life. To me, this is the endpoint that really matters to all of us. This is that subjective well-being, satisfaction with life. This is the piece of life that we use to judge whether or not our life is meaningful, rewarding, satisfying. It's that personal relevance factor of life. And what we've shown is that exercise training, in addition to all those other outcomes, can improve one's satisfaction with their life. And I think that that is, at the end of the day, probably the biggest benefit of exercise training is to improve whether or not people believe that they live a life that's worth living. And there are lots of other outcomes that have been studied in the context of exercise and physical activity, and I bring this to summarize everything that we know. This is a paper that we published in Nature Reviews Neurology a few years ago, and the effect of exercise has been studied across all of these different outcomes. And the effects of exercise on MS pathogenic processes like inflammation and neurodegenerative processes has been slowly studied. It's not a very compelling story yet. The effects of exercise on axonal damage and neuronal loss, we're beginning to show that exercise has an effect there. So maybe if we should be very careful and say that it looks promising that exercise might have an important effect on managing the course of multiple sclerosis as a disease. We can very strongly say that there is a good case for exercise and symptom management by looking at a lot of these important outcomes: fatigue, depression, aerobic power or fitness, gait, muscle strength, and potentially cognition and balance, walking performance, and quality of life. So I think we have really good news for people with MS about the benefits of exercise. We can very, very assuredly say that exercise is good for managing many of the consequences, and I think that we're going to build the story for exercise as a disease-modifying therapy over time. So I think this is great news, but we have to contextualize it, because we need to talk about one of the problems that we also have to address, and that problem is rates of participation with exercise and physical activity in multiple sclerosis. So this is a paper, and one of the first papers that we really published to get us rolling in this area of physical activity and multiple sclerosis. And it was a meta-analysis to understand how physically active people with multiple sclerosis are relative to the general population. And what we found when we looked at all the studies that compared people with MS to the general population is that people with MS were substantially less physically active, 1 standard deviation less physically active than the general population. And I think that that's not surprising to anybody in this room. I think that there are a lot of very salient and good reasons for the low rate of uptake and physical activity participation in persons with multiple sclerosis. But I think we have to put this into context. And that context is that the general population, which is the comparator group, fewer than 60% of them are participating in physical activity that introduces health benefits. And persons with MS are 1 standard deviation less physically active. So this really puts us at risk for all of the other deleterious consequences of an inactive lifestyle. We wanted to follow this up a few years ago, and one of my graduate students, Rachel Claren in particular, was interested in saying, well, maybe that is just a self-reported artifact. People are saying I don't engage in a lot of physical activity, people with MS are saying that, but maybe if we use these fancy devices that are called accelerometers that track how physically active people are, that don't have self-report bias associated with them, maybe that'll tell us a different story. And so Rachel analyzed about 800 cases of persons with MS and 200 controls, and what she reported is the rate of moderate to vigorous physical activity is very different in MS than it is in controls. People with MS are on average accumulating about 15 minutes less moderate to vigorous physical activity per day compared to the general population. Now, to put that into context of meeting public health goals, what we found is that this translates into 40% of our sample was engaging, 40% of the control samples was engaging in appropriate amounts of moderate to vigorous physical activity. Fewer than 20% of the people with MS were. And so it really has highlighted a very important conundrum for us. We have, on the one side, lots of very powerful data about the benefits of exercise, but on the other side, we have a common problem, and that is changing the uptake of physical activity behavior in MS. We've created all this great knowledge, but we haven't figured out a way to help people with MS know what to do. And that's a major failing on the researcher's side, not on y'all's side. So I was fortunate enough a few years ago to be invited to help develop prescriptive guidelines for exercise in persons with multiple sclerosis. And this was a project that Lara Paluti was involved in, that I was involved in, with McMaster and Queen's University in Canada. And we developed something that was called the Canadian Physical Activity Guidelines. I'm not quite sure these are specific to Canadians, but nevertheless, we called them the Canadian Physical Activity Guidelines. Sometimes scientists aren't very smart. And we developed these guidelines based on the scientific evidence. We went through this approach where first we identified all of the scientific evidence that had been conducted on exercise and physical activity in MS, and we used the highest quality data we could find. And from those studies, we looked at which of the studies resulted in beneficial changes and which of the studies didn't. And then what we did is we looked at the characteristics of the studies that promoted benefits or yielded benefits and the characteristics of the studies that didn't. And that developed our guidelines or our prescription because we felt that systematically there was a pattern of exercise that was occurring in the studies that resulted in benefits. So we developed our guidelines. And we didn't stop there. We then sent it out to a consensus panel of experts to get their evaluation of whether or not our guidelines were consistent with evidence. That is, sometimes scientists bring a lens and view evidence in a manner that might not be as accurate as possible. And so we wanted independent individuals to say whether or not we were right or wrong, and they unanimously agreed that we were right in what we created. So then we went and sought stakeholder involvement. We went and found exercise professionals who work with individuals with MS. We found physicians and service providers for rating the consistency between the evidence and the guidelines. So we went one step further than a panel and went to actually frontline individuals and asked them for this. And the reason I'm going through this is because I want you to understand how rigorously developed these guidelines were. And they basically told us, you guys got it right. We're kind of feeling pretty good about ourselves at that point in time. We then went and sought additional feedback. We went to patients with MS. And we recruited 112 of them and asked them for their feedback. We went to healthcare professionals and asked them for their feedback. Again, to understand whether or not we got it right and whether or not the guidelines were usable for people with multiple sclerosis. And we evaluated their responses using these very specific agree-to evaluative criteria. And universally, people loved what we created. And this is the product. The product says that individuals with multiple sclerosis need to engage in aerobic exercise and strength training exercise. Not one or the other, but both. They need to engage in 2 days per week of aerobic exercise and 2 times per week of resistance exercise. The one good thing is that those could be done on the same day. We just need to make sure that we get 4 exercise sessions in a week, 2 that are aerobic and 2 that are resistance or muscle training. We need to gradually develop the physical activity over time. Individuals need to start slow. That is, start with something that is manageable and doable, and based on the experiences they have, slowly increase their physical activity by adding more aerobic exercise from a duration perspective and resistance exercise from a number of repetitions and sets perspective. How hard did this need to be? When people were engaging in aerobic exercise, we needed to give some guidelines for what that aerobic exercise should be. And we utilized the SPEAK test. If you're engaging in aerobic exercise and you're out walking and you can have a great conversation without losing your breath, you're not exercising hard enough. If you're out walking with someone and you can't get in any words into a conversation, you're walking too hard or exercising too hard. We want people to be able to exercise, have a little bit of difficulty in being able to hold on along with a prolonged conversation, okay? That's the guideline for moderate exercise when it's aerobic. With resistance exercise, we wanted people to pick something that got them to failure after doing between 10 and 15 repetitions, and then slowly progress from there. And how to do it. With aerobic exercise, there were lots of different options. We suggested that people could do walking or leg cycling exercise because those seem to be or have the greatest degree of evidence. We suggested that people could do elliptical exercise, and I just had a really, really great conversation today about someone who's engaged in elliptical exercise and seen just unbelievable benefits. Or they could engage in arm ergometry if walking and cycling with the lower legs are no longer possible, so pedaling an arm bike. From a resistance exercise, we thought that people could use weight training machines, they could use free weights, or they could use cable pulleys. There are other types of exercise that people could do. For example, individuals could use elastic resistance bands. That was a good alternative option if you don't have access to a gym. The idea of aquatic exercise, I know, is quite large in the world of multiple sclerosis, and I hate to say this because everybody wants to kill me from the MS Society when I do, but there are no data really supporting aquatic exercise as having great benefits in MS yet. We're working on it, but the data aren't there yet. I'm not telling you don't do it, but just buyer beware. The data don't support it yet. So what we've done is we've created a guideline. And this guideline, if you just type into your web browser, Canadian Guidelines for Physical Activity, is posted by the MS Society of Canada, the Canadian Society for Exercise Physiologists, and other groups. Maybe someone in the United States will post it. I think we might. Looking ahead, what do we need to do? Well, I think we've entered into the time where we need to look at exercise in direct comparison to pharmacological agents that modify the disease. This is a very, very, very controversial paper by a gentleman by the name of John Ioannidis. And John Ioannidis is a philosopher as well as a protagonist of the world of science. He's written papers why most scientific findings are false, where he has basically challenged scientists to rethink what they're reporting and whether or not it's true. And in this paper, he wrote about the comparative effectiveness of exercise and drug interventions on different outcomes, particularly mortality outcomes. And this was a paper that was published in the British Medical Journal, which is a very prestigious journal. And what he concludes in here is that the findings of our review suggest that exercise and many drug interventions are often potentially similar in terms of their mortality benefits. Similar in terms of their mortality benefits. And in the paper, they go further to suggest they're similar in terms of morbidity or disease. Exercise interventions, therefore, should be considered as a viable alternative or alongside drug therapy. He goes even one step further than that in this paper. Down here in the underlying text, he says something quite strong. Regulators should consider requiring pharmaceutical sponsors of new drugs to include exercise interventions as an active comparator arm in drug trials. He is suggesting that if you want to do a drug trial, you don't compare it to a placebo medication or another medication, you compare it directly to exercise. It's a pretty strong statement. I'll leave it to the rest of the room to digest that. We need to understand more about the mechanisms of exercise. If we truly do believe that exercise is a disease-modifying therapy, we probably need to spend a lot more time looking at the effects of exercise on immunomodulation. We need to look and see whether or not exercise improves anti-inflammatory processes and decreases pro-inflammatory processes. There are lots of data in the world of gerontology that supports this idea. We need to do a better job of understanding this in multiple sclerosis, particularly during acute periods of disease activity, i.e. a relapse, which we're currently doing in Ireland. It was easier to do that there than here in the United States for whatever reason. We need to further look at the effects of exercise on brain health and processes associated with improving brain health, to understand the mechanisms of whether or not exercise really does alter the disease and the disease course, and whether or not this is explained by the immune process or brain health. We lastly need to know a lot more about how to promote exercise behavior in persons with MS. This is a recent study that we completed with funding by the National MS Society, where we had a novel idea. Let's talk to people with MS about what they want for promoting exercise. Scientists are slow sometimes to come around to people and ask them the right questions. What we did is we asked individuals about their views and ideas on exercise and how it could be promoted specifically through healthcare providers. And we were very intrigued at what they found. Universally, patients said, I want exercise to be promoted in the context of interactions with my healthcare provider. Universally. When I go see my neurologist in particular was one of the main quotes that we heard. I want my neurologist to help me understand how to engage in exercise. Now, I realize that that puts a lot of strain and burden on an already burdensome process, but it's what patients seemingly want. They further told us about what they wanted. They said they want promotion to come from healthcare providers, particularly neurologists. They want a lot of information about materials. That is, give me materials that can help me to understand what I need to do to engage exercise into my life. They said, give me knowledge. Help me understand where I can learn more about exercise. They also wanted behavioral strategies. Teach me not only about how to engage in exercise and why exercise is good for me and what it can do, but teach me how to regulate this process long term. That is, over the course of my disease, help me to become a regular exerciser. Teach me the skills. Whew, that's a lot to ask from a neurologist. They further gave us a lot of insight on what specific things they want and how to deliver it. Fortunately, they told us that they wanted a lot of this information through paper-type forms, brochures, things along that line, as well as through the internet as a source or mechanism of delivery. So maybe this is good news because it takes some of the pressure off of this context. We've been very fortunate to be able to expand this knowledge. We recently received funding from the National MS Society from the Healthcare Delivery and Policy Research Mechanisms, and they are funding a project called COMPLETE, Coordinated Multiple Sclerosis Exercise Toolkit. We are now going to the healthcare providers with these data, and we are asking them, what do you think about this? We need to get the healthcare providers' perspectives on what is possible in the context of the healthcare setting. So all the healthcare providers in the room, we will be in contact with you in the very near future to set up a time to interview you and find out what we can do. We're going to gather the knowledge from providers and patients and develop a conceptual model that defines the process of how this will occur. We're going to then refine that conceptual model and develop a toolkit, some sort of almost package in a box, so to speak, that can be put in every MS care center throughout the United States, maybe even worldwide, that providers can use to promote exercise and physical activity in MS and facilitate this behavior change. And then we will evaluate whether or not this toolkit works and how to change it. This will all be done in the next 3 years. No pressure. The last thing I want to bring up is that we've all become a little bit more sedentary. I'm a professor. I sit at a desk 10 hours a day. But I'm also a kinesiologist, and I know that I need to exercise. Sedentary behavior is killing us. It is considered to be the smoking of the 21st century. A lot of this has to do with the way that we've designed society. We've designed society to where people have changed over time to be modern-day professors who sit at a computer all day. We need to change this, and we are working on this very, very diligently to understand how we can develop programs and interventions to help people with MS in particular become less sedentary. The last good news, the MS Society has started a health and wellness initiative. They've started an initiative around the behaviors that you can do to promote health and wellness with MS. We hosted our first meeting last year in Dallas to begin to address the agenda. Barb Applebaum, who will be speaking today, was front and center in this process, and this was the jumpstart to the Health and Wellness Initiative. We are meeting next week, I hope, in Washington, D.C., a smaller group, to define the agenda. And this agenda will consist of a makeover from programs through research from the MS Society on how to define health and wellness in MS. This is an exciting time, and this is directly from the feedback that the MS Society has obtained from individuals living with multiple sclerosis. Before I end, let me make a few acknowledgments. We have without a doubt, been blessed by many, many, many participants in the state of Illinois. That without the willingness of these individuals to sometimes travel great distances to come to our labs, much of what we've done and much of what we do can't be possible. So we are, and I'm truly grateful for the participants. The second reason I'm grateful for the participants is because they tell me stories. And the stories reinforce me to continue doing what I want. One of our participants started one of our programs with the desire to be able to walk her son down the aisle when he was getting married. And at the end of the program, not only did she have the capacity to walk him down the aisle, she danced with him during the first dance. And to me, that's why we do what we do. I'm blessed by unbelievable graduate students, many who are sitting at that table over there. You guys raise your hand. Right over there. Kylie, raise your hands. I have unbelievable graduate students, undergraduates, who I get the privilege of working with, and for that matter. I have postdoctoral fellows that are second to none. They have finished their PhDs, and they've come to me and entrusted me in helping them learn more and to do more meaningful research. One of them, Lara Paludi, has turned into a colleague of mine at the University of Illinois who is leading the efforts. Lara, raise your hand. You'll see her this afternoon. Leading the efforts in exercise and advanced MS. And I have other colleagues who have contributed greatly to this work. It's amazing. And I'm just grateful for all the funding and support that we've received over the year. And this is a picture of my lab group here. Apparently, I don't change my suit and shirt very often. This is Lizzie Hubbard, Dom Hopkins, Bryn Adamson, Ipek Ansari, Rachel Claren, and Julia Balto. They're all graduate students obtaining their PhD. This is Emerson Sebastião and Yvonne Lermont. They're doing postdocs. And this is Sarah Summers, who is the lab coordinator, who you probably have all had the unbelievable privilege of talking to over time. And if you ever call the lab, you'll reach her first. If you call the lab itself through this 800 number, or if you send us an email, and she will give you every piece of information you can with no pressure at all to participate. If you're interested in ever contacting me, this is my direct information. That's my direct phone number, and that is my direct email. I do answer my own phone, and I do respond to my own email, and I will respond to you. Thank you.